I'm Mohsen Kavrat. I'm a professor in electrical engineering at the Pennsylvania State University. Recently, with a team of my graduate students, we have developed a quick lab demonstration using, for the most part, off-the-shelf components for an optical wireless link that hopefully can show you the potential of this technology. Of course, this is not the final product, and obviously it is just emulating the basic principles. But the point is, we can transfer the entire band or the enormous band of a single mode fiber onto a wireless optical link in our lab. Okay, so now we slowly go over what this link is made of. To start with, we have cable TV outlet only in one location in this lab. And as you can see here, coax cable brings many high resolution TV channels into an optical head-end transmitter, which then modulates single mode light at 1550 nanometer. And the light is coupled into single mode fiber and is carried right into a collimating lens, which then transmits the modulated light, carrying all these TV channels to a receiver over air, and the receiver is 15 meters away from this location. Okay, so now we are 15 meters away from the transmit unit. And as you see, a receive collimating lens assembly focuses the receive light, which is bringing those high resolution TV channels via single mode fiber, and the fiber feeds the light into an optical receiver, which then separates the TV channels, and via this coaxial cable that you see here, those signals are connected to the back of this LED panel, and you see the very nice and high resolution of the TV signals. So the transmission over this path, which could be much longer actually, but that basically 15 meters is the length of our lab here. It can be extended to many more meters and even miles if such an area exists. We have plenty of link margin or power, extra power, that the signal could go much farther. The point being that transmission over air in a temperature-controlled indoors environment is virtually lossless. In other words, outdoor we have to overcome the atmospheric turbulence due to temperature change, wind, and elevation on a vertical link, whereas on a horizontal link indoors, if the environment is temperature controlled, there is basically no distortion in the wavefront, and the signal is received lossless. The only losses are receiving this signal via lens and coupling into single mode fiber, which, as you know, has a very small diameter in the order of less than 10 micrometers. So that's the only loss. And so long as sufficient power is being received, you will have a very high signal to noise ratio. Consequently, you can display thousands of high resolution TV channels. Basically, the entire optical band is available to us. So this is just the start for our continued demonstrations with very high speed data links that will be multiplexed along with this TV signals. We have the wavelength division multiplexing capability in the transmitter, so we can add on new features and links and much higher speed transmissions. 10 gigabit two-directional transmission can be an easy augmentation to this link. And beyond that, as the technology and the standards are moving, 40 gigabit and 100 gigabit is possibility. And since fiber, single mode fiber, offers terahertz of bandwidth, so that virtually can be transferred to transmission over air. Now, just to prove the point that the signal is really being carried via air and being received via the lens, I'm going to block the light being received, and hopefully in one shot you can see the LED monitor and the receiver at the same time. And as soon as I block the light, as you see, the TV signal disappears. And as I remove the obstacle, the signal comes back on instantly, and we have the same high resolution transmission. So this is a pointed stationary link. As you can see, there is no mechanism for dynamic tracking of the beam. Once you align the transmitter and receiver, basically remains delivering high quality signal, unless somehow the link is obstructed. So unobstructed, you will enjoy error-free transmission in digital and very high signal to noise ratios when you're sending analog signals. Of course, this is a stationary link, and there is more research need to be done to add mobility features to this transmission environment. Basically, you need to diffuse the light to provide mobility so you can roam around with the receiver. I hope with this short video we managed to demonstrate to you the potential of this technology, and I thank you very much for your attention.